Hello Internet, welcome back. So you may remember where we were last time. We were working with our fractal tree. It kind of looked like this. Well, it should have looked exactly like this. What we're going to do now is we're going to move on and do some other fractal work. So we're kind of dropping this tree idea and we're moving on to probably the most classic of all fractals. We're going to work with the Mandelbrot set. And to do that, we're actually going to create a shader that's going to render it. So what I've done is we're not going to come up with the formulas ourselves because I don't know them and because that would just be horribly painful to go through all that math. But what we do have is I have a Microsoft blog here from a developer at Microsoft who is working in XNA. And so we're going to take that shader and we're going to translate it into a Unity surface shader. And so that's pretty much what this is going to be. So to do that, we're going to abandon this guy, this falling over tree thing, and we're going to jump into a new scene, our 2D fractal scene. And so we're going to adjust our scene again, change the color to black just so it looks exactly like the old one. And then we are going to create a new folder for our shaders. And we're going to call it our Mandelbrot set shader. Once we find the shader bit. That shouldn't have been that hard. Apparently it was. Okay. Come on. Can't be that hard. I can't remember how to spell. I'll get that back in a second, sorry. Mandelbrot shader. Cool. So there's that. There's the blog post we're going to be using. And I'll just stick that there. This guy, we're going to open him up. And we're going to get a bunch of stuff in Unity. If you saw my original videos, the first two on creating a flat shader, this should look familiar because it's the exact same thing. Hopefully we don't screw up as much. Hopefully I've learned something. So what we're going to do is we're going to take what's in here, which is actually fairly simple, and we should get something that looks like this guy. So that's what we're going for. And so we're going to kind of step through this step by step, and then at the end we're going to assign it to a material and see if it worked. And if it doesn't, then we'll figure it out from there. So a lot of this stuff is more stuff we don't need. So I'm going to drop all of that. And I don't think we need the color either, but just for now, I'm going to keep that. Can get rid of those. Actually, instead of making this hard, I'm just going to keep all of this. It won't really hurt that much since it's there. So we're going to keep it and we can get rid of stuff later. The next thing I'm going to do is I'm going to actually pop this guy out and do that. And we'll get that side by side. We don't really need all the other Visual Studio stuff. We just need a code editor. So this will work great for us. Then what we need to do is take this surface function. And this needs to more or less translate exactly into our pixel shader. So instead of returning a float 4 here, we want to eventually assign our albedo and probably our emission to this result. And so we can just start plugging things in. They've got a float 2. That's C. I'm going to comment this one out because we have a different C. And we can go back right now. We're not going to worry about improving this code or doing anything like that. All we're doing is translating it verbatim into Unity surface shader code. And then we can go back and refactor things and make the code nicer and whatever. So what we're taking is we're taking our UV coordinates from our main texture. So these are going to be our UV coordinates on our plane. So they're going to be from 0 to 1 and respectively, and they're going to map to our shaders. And we're going to subtract 0.5, so this should get our shader, so the range is from -0.5 to 0.5 on the entire scale. And we're going to multiply that by our zoom which we don't have. We'll have to add that. And we're going to multiply it by our float of our aspect ratio. And so this is going to, it should expand that horizontally. Vertically, actually. It's going to expand it vertically because that's the y vector. And then we have our pan, which is also going to be a vector too. So I'm going to do pan.xy and zoom.xy. And that's because I believe Unity only accepts vectors as a vector 4. So that's going to be x or w, x, y, z. So we just want the x and y coordinates here. And we might even be able, if we wanted to worry about optimization later, we could probably do like x, y, and z, w and use just one vector for the whole thing. But we don't need to worry about that for now. Next, we've got our float of v, which is 0, and our float of m, which is also 0. And then we also have, does constant work? Float r equals 5. Next, we're going to take this for loop and just iterate over n from the number of iterations, which is another thing we're going to need as a parameter to, yeah. So we're going to iterate n times, or iteration times, and then we're going to calculate something. We're going to calculate v. So v is going to equal the float 2, so two-dimensional vector of v.x times v.x, so v.x squared minus the y component squared. And then we are going to multiply the two components together. So v.x times v.y, and we're going to multiply that by 2. And then we're going to add our c value, which I believe is our just a standing, c seems to be standing for a constant in this formula. Next, we have a dot product of our vector. So this should always just return the length. If I'm reading this correctly, it should always return the length of our vector. I believe that's what the dot product of the two things would be. Yeah, that makes sense. And then we want to multiply our r value, square that, and subtract 1. There we go. So assuming the length is less than r squared minus 1, so this is looking like it's going to be 24. And so assuming the length is less than 24, we want to increment our m variable. I'm going to stick some brackets around there, not because they're needed, but because they make me happy. Next, we are going to set our, we're going to clamp our v vector. Yeah, okay. So we're clamping v between our r values. So this will clamp it between -5 and 5. I don't know if this exists in Unity, if the clamp function exists, but we're going to try. So if m equals our iterations, then we want to return 0. This isn't actually going to work. I'm just writing that for now. And then otherwise, we want to return a float 4 of the sine of m over 4, the sine of m over 5, and the sine of m over 7. So that's our red, green, and blue values. And then we want it to be opaque, so set the opacity to 1. Next, we'll divide it by 4 and add 0.75. So this gets us a value that's going to be between 0.75 and 1. And then we can go from there. Right, so the next step, we want to take this, set our float for, and we'll just save this as our color. And so the color is going to be empty, and that's what we're going to return here. So now our color is going to be equal to a float for of 0, 0, 0, and 0, 1. We'll set it to 1 there. So it'll be black. And then this one will be our color. And then we can set our albedo equal to the color, and we can also set the emission equal to the color. And so that should be everything we need. The only other thing to do is we need to get all of our values set. So we have in iterations, which is going to be this. So we are going to need an int called iterations, and we can just do this. We're going to need 2 vectors. So we have a zoom, and that's going to be our zoom. It's going to be a vector, not a vector 3. That is the wrong thing. Vector, and 0, 0, 0, and 0. Actually, let's do this all ones. I think that makes more sense, because otherwise that will just take our C and set it to 0. And I don't think that would look good. So zoom, we also have our aspect ratio and our pan. So we can do our pan next because it's also a vector. Set our vector, not a vector 3 again. There we go. And then we also need to do our iterations and our zoom. So we can do, or not our zoom, we need to do our aspect. So the aspect ratio is going to be that times, what do we want this to be? This could be a range. Does it need to be? You can just float. Sure, and we'll set that to 1 for now, and we'll just do a square. The next is our iterations, and this can be iterations range from 1 to 20. I don't know what a good number is here. I've never done this before, so we'll see what happens. I'm gonna give it a default of 10, because why not? So I think that's all we need. This metallic, smoothness, and alpha, we can kind of get rid of those. This can be our color value, so our alpha will be our color.a, and that should be it. The only other thing we need is this. I believe those can be floats. And then we need 2 vectors. So this will be a float of 4 of our zoom and a float 4 of our pan. And I think that's it. We don't need glossiness, metallic, or color. We do need our main texture because we're using the main texture's UV coordinates. There's probably a better way to get the UV coordinates from the mesh, but I don't know it. So for now, we're just going to stick with that. So I'm going to remove those. And this should be good. The only thing I'm going to change now is we're going to set this name. And we're going to put it in a Fractal folder. So it's going to be under Fractals Mandelbrot. And we get a bunch of errors. Cool. Unexpected token. That's not the right place. So in here, we have an unexpected token. Divided by 4. Oh, we don't need that. That's a C# thing. So that can go away. No, can't go away. At line 55, it expects a... Oh, there we go. We weren't setting that. Now we are. Cool. So that goes away. Too much data in type constructor at line 53. So we did something wrong here. Float 4, not float. So when the number we put after that float represents the size of the vector. So we can put 3, 2, 4, whatever, and it just gets us something that contains 4 elements, 3 elements, etc. So we can do that. That fixes that. And then our iterations is undefined because it needs to have an underscore. And we're going to get this error for everything. So we can copy this, paste that, do that, and do this. And I think that is all of them. So now we've got our underscores going under everything. Cool. So that should work. All of those are gone. Awesome. So what we're going to do next is I'm going to create another folder for materials because it keeps things separate. And we're going to drop our material in there. So Mandelbrot set. Cool. Then what we can do is we can look under our fractal and assign it this. And we get something that looks horrible. It's kind of there. One sec. I think we just need to tweak some values. So I'm going to create a new quad. There it is. Drop that guy on there. And we get something that looks something like something. That was a great sentence. I'm going to blow this guy up to somewhat useful proportions. And we get something in the top right corner. So that's looking somewhat intelligent. But everything else is not what we want. I can remove the mesh collider. That's not needed. We're not going to collide with this at all. We're just drawing things. Iterations. Okay, so 10 seems a little bit short. And 20 seems good-ish. We get more definition. Obviously, as we reduce the number of iterations, it kind of goes away. I'm kind of curious why it is flickering. So if I do 11, 12, 12.5, I don't know why it's going away. I'll just open up Visual Studio Code because I don't know why. Can close that. If m is equal to the iterations, mathf dot the floor, that's why. So it wasn't equaling the iterations, which is part of our problem. There we go. And then I'm also going to go in here and actually pull out that emission thing. I don't really want that. And we get something a little bit more coherent. The emission is the light that is actually emitted without any light on the object. And so by removing that, we get a little bit more definition. So you can see as we increase the iterations, we get more and more definition. What I am going to do is go in here and increase the range that's allowed on this to something bigger, 64 let's say, and set the default to like 32. Just so we can get way more going here. There we go. Okay, so we can iterate a ton on this, which is cool. And we can zoom. You can see it's just a little bit off the page. So what we can do is go to 0, 0, and we'll get that, and zoom out. or sorry, zoom in. So those numbers go backwards. I wonder why that is. Let me see if I can figure that out. So as the C seems to be increasing, the set seems to be decreasing. So this is almost a direct relation to zooming out. But as you can see, we did get our Mandelbrot set, and it looks awesome. But what we can do now is zoom whoa, not that far in, zoom way in, and pan a little bit, and we can actually like see things going on here. So what we've done is we've successfully translated this guy over to this guy, and I can actually just keep going and zooming in and in and in. Let's go to 0.1. And so the cool thing is, as fractals do, it keeps generating copies of itself, more and more and more. Yeah, ta-da. But there's one more thing that this does. This, there isn't just this fractal that's being generated. There's actually a second one that is also capable from these things, and that's called the Julia set. I think it's pronounced Julia. I assume so. And so we're also going to solve for that. And it's just a simple modification from the current one we have. So we're going to create another shader, if I don't get lost again. And we're going to call it Julia. Cool. Thank you for, whoa. Thank you for that. And we're going to snap that over there, grab you. And then I'm just going to copy and paste the entire thing and rename the shader to Julia. And that, oops, and that should be everything we need. Now the only other thing we need to do is change these things. So all we're changing is this. Done. And we lost a few of our things. Well, actually, I'm going to keep this, and we're going to take this because this is exactly what we had for our V value. It's exactly the same. And so that just becomes our V, and our C becomes our color, which I don't think was specified. So how does this work? If I remember correctly, I was reading this before, and the color is used for something. The color is the seed. So we're not going to accept the color. We're actually going to use a seed value. And so this can be our seed. Cool. So the seed is going to be the color. No, the seed is going to be the seed, and the seed is going to be a vector. So the vector is going to do, we're going to default that to 0.5 and 0.5 and so forth, just like they have down here. I keep pointing at my screen. You guys can't see me pointing at that. It's not on camera. So there we have our seed. We're going to pass that in as the color. And then we can actually change that because the cool thing with this fractal is it totally changes as the seed changes. And these are just some of what you can do with it. We're going to get a few other ones, I think. And that should be the only changes we needed. So everything else should be the exact same. I've never done this before, so I could be totally wrong here. We forgot to define our seed. Float 4, set our seed. Cool, that should be good. Get back out here. And then I'm gonna create another material for our Julia set. And we'll go into the fractals, Julia. The texture doesn't matter. We can just drop that. Oops, Drop that on there. And change the pan. And we can go back into our game view, increase the iterations because more is always better. And then we can adjust the seeds. So it kind of does some cool stuff there. Well, that's actually really sweet. So fractals, they're awesome. So yeah, as this one is really neat because we get totally different stuff as this changes. I think we're kind of running long on this one, but I think the next one, next video, what we're going to do is we're going to animate the seed value so that it moves over time. We're going to write a script that's going to send data to our shaders. I think that's the next step. So I hope this was interesting. I found it interesting. I hope you didn't mind me skipping over all of the math stuff. If you want to read more about that, I'll stick a description about the math behind these in the description, so check that out. And you can learn some more about the actual math that's involved in generating these things. I'm not going to get into that because I don't understand it. Well, not that I don't understand it, I just don't understand it enough to explain it in a way that wouldn't totally confuse everybody, because I don't have that kind of knowledge on it. I'm rambling. So anyway, thanks for watching. Hope you liked it. Make sure to like, subscribe, comment, whatever. Yeah, thanks for watching. See you, internet.